This video is to help you review for your math skills practice. All over this document are hints and tips and notes. It is your responsibility to go through and check out this playlist. Read these skills so you know what you're responsible for. Check out these links. This document is available on the announcements for math skills, so you can download it, print it. It's 6 pages. You can just open it up on your laptop and click these links. There's more review, there's information. Alternatively, you can just Google these topics and find plenty of reputable websites for math review. I'm going to go through 1 or 2 examples from each section, and you can go back and do the other pieces, and I will post answers so you can check them in a separate document. So when you do order of operations, you have to do what's in parentheses first. So this is going to simplify to 7 squared times 5 minus 10 plus 5 squared. So this is 49 times 5 minus 10 plus 25. And then you can do 49 times 5, which is 245 minus 10 plus 25. And then you just go across and do it in order. And you are welcome to use a calculator to do these things. I don't expect you to do them in your head, but you need to know this order of operations. You have to be able to do it the correct way. So here's the answer right here. Here's 2 more examples. Make sure you can do it manually. Don't just plug it into your calculator because then you won't know if you understand the concept. So let's do this. Your job is to rearrange these equations. So I'm going to do 2 examples with you. I'm going to do them on a separate sheet because there's not enough room on here. So we're going to do, first thing you do is write out the equation. I'm solving for A. That's what subject is. Subject is what you're solving for. That's explained in the heading, so you can read that. So if I want to solve for A, there's 2 ways you can do that. Because A is in the denominator, you can multiply both sides by A, and you get IA equals P, and then divide both sides by I. So that's one way of doing it. Here's the answer. A second alternative way of doing this is to, which I like quite a bit, is to put this over 1 and cross multiply. That's my favorite way to do these types of problems. So this would be P times 1 is P and I times A. And you end up, you notice, with the same thing. Then you have to divide both sides by I to get A by itself. It doesn't matter which way you do it, you end up with the same result. So just find a way that works. If you wanted, if we do this one, y equals 2 minus 1 over x, to isolate x, you have to first subtract 2. So you get y minus 2 equals negative 1 over x. You got to get rid of the negative sign by multiplying by negative 1 or dividing by negative 1. It doesn't really matter. So you get negative y plus 2 equals 1 over x. And then you have 2 options. You can either cross multiply, or you can take the reciprocal of both sides. The reciprocal of both sides is taking it to a power of negative 1. So you have you have a choice. Now you have x equals negative y plus 2 raised to the negative 1 power, which is the same as saying negative y, 1 over negative y plus 2. Alternatively, you could rearrange the bottom to do 2 minus y. I mean, these are all equal to each other, and I don't really care which way you write it. Any of these 3 would be acceptable as long as you understand what that exponent means. Okay. So writing word problems, writing out word problems, there you must show your work. You can't, I don't want you just plugging in numbers. Here's some helpful hints for those of you who don't remember the cues. So it says Jessica picked 48 lemons. So the number of lemons, and this is for Jessica, is 48. And she did number of pears. So we're going to write down all the stuff we're told. And you can make up symbols for this too. So you might say L for Jessica, right? And this is P for Jessica. Jessica gives Mary 15 of her lemons. So number of lemons for Mary is 15. So that's lemons for Mary. And the number of pears for Mary is 19. So that's P for Mary. So you're making up symbols that are descriptive, so you'll remember them for each one. These are not like official symbols, but it'll help. Tim has 2 times the amount of Jessica's lemons squared. So what does that look like? So we're talking about lemons. So this is Tim's lemons. Okay, so we don't know how many he has because that's what we're looking for. So that's a question mark. And but we have this equation, so we're gonna write out the equation. So look what we did. We created symbols for all given information and the unknown. We identified the values associated. That's what that is. Here's the symbols, right, for all these things. Here's the values. So we're identifying everything. Write the algebraic expression for the word problem. That's what we're doing now. Tim's lemons is 2 times the amount of Jessica's lemons squared. Okay. The problem is that Jessica gave Mary 15 of her lemons. So Jessica doesn't have 48 anymore. So we need her second amount, right? This is her first amount. And since she gives some of them away, we're going to say that that Jessica's second amount of lemons is her first amount of lemons minus the amount she gave to Mary. So we first have to do that. 48 minus 15 is going to be 33. So that's the amount that she has. This goes in there. So now we can solve it. So 2 times 33 squared. So 66, but this is a silly number, right? Squared, he has 4,356. That's how many lemons Tim has. So that's, ridiculous, but it doesn't matter. You're solving the problem using your algebra skills, and you're making sure you're reading well. So precision and accuracy. There's again a bunch of resources. Here's what you have to know. Here's some of the definitions. Now you got to be able to use them, right? So you measured your weight 5 times. If the doctor says your weight is actually 60.7 kilograms, create a data set that meets the following criteria: accurate but not precise. So if it's actually 60.7, those values, if you want them to be accurate, have to average out to be 60.7, right? But if it's not precise, that means they're kind of scattered all over the place. So you might start out by saying, well, I'm going to do 50.7 and 70.7 and 55.7 and 65.3 and 60.1. And if you average those out, they'll be pretty close to 60.7, but they're widely spread on either side of this value it's supposed to be. So not precise means it's not consistent. Accurate means they average out to be that value. So you could do that on your calculator and figure that out. You can estimate as well. Precise but not accurate. Precise means they're clustered together. They're very consistent, but they're not close to what they should be. So you could say, oh, we got 48.2, 47.9, 48.0, 47.8, and 48.1. Those are all tightly clustered, but they're not close to what they should be. Accurate and precise would be that they're tightly clustered and they average out to be what they should be, right? So you could make up any values you want, right, that are pretty close to what they should be. So those are tightly clustered around this value, right? And then neither accurate nor precise would be scattered wildly, not even close to what they should be, right? So you're going to have, 10 point. You could really make up anything. Right, you see, so that's how you figure that out. So you can either make up data sets or you can evaluate data sets that you're given. Significant figures. So there's tons of really great resources online. ChemTeam is a great website that you should have learned about when you took chemistry, but they have really good worksheets and information on it. But here are the rules. You need to know the rules, okay? So when you look at these examples, any non-zero digit is significant, right? So the 3 and the 8 are definitely significant. Any zeros between two significant figures are significant. So this is significant also. So we've got these 3 digits are significant. A final 0 or trailing 0 in the decimal portion are significant. So these are all significant. That's 5. In here, we've got all non-zero digits. There's no zeros between them. These are not trailing zeros, so they don't count. They're placeholders so that you know that it's in the 1000th place. So there's just 3 there. So there's there's more examples here. Now when you do calculations, right, the appropriate number is the least amount of sig figs. So you can't just plug it into your calculator and use what your calculator gives you. Now you can certainly use your calculator to figure stuff out, right? So, I mean, if you take this example and you do 3.4617 exponent, right, 10 to the negative 7, 10 to the 7, divided by 5.61, right, and I'm using the exponent key to make sure that I group those properly, or you can, well, you do it how you want. So you get 6.170588, right? So how do you express that to the correct number of decimal places using the right number sig figs? So you have to look at this number, and this is 1, 2, 3, 4, 5. This has 5 sig figs. This only has 3. So you can only express just this number to 3. So if I round this correctly, I'm going to get 6.17, right? It rounds that. And now I don't want to forget my exponent, which is over there. So this is the correct value. You're never going to ask me how many places I want, because you need to know this. All right, so you do these other examples and make sure you understand. Units of measurement. So you need to know how to convert from one unit to another. You must use units for any quantity that you're given. In physics, we only use kilograms, seconds, and meters, although occasionally you'll use grams and centimeters, but you really can't leave numbers in those units because they're not useful to us. So what I want you also to know, what is the general size of a kilogram and a second and a meter? So you want to look that up. I mean, a kilogram is about 2.2 pounds. It's about 2 pounds. So whenever you're given kilograms, so that you have a good sense of what it is, you should multiply by 2 and know it's a little bit more than that. If you want to know your weight in kilograms, if you're 120 pounds, you're going to be about 60 kilograms, a little less. So that's how you figure that stuff out. Anyway, 12 inches. So if you don't know the conversion from inches to centimeters, look it up. But it's a useful thing to know that 1 inch is 2.54 centimeters. Some things are worth memorizing, but you can always look that up. So you have 12 inches and you want to convert, you have to use a conversion factor. Since these two are equivalent, it's like multiplying by 1. So we have to use dimensional analysis. You're not allowed to use proportions in this class. They're just very limited in terms of their usefulness. So 12 times 2.54 is 30.48 centimeters. Okay? Excuse me. So now to go from grams to milligrams, you need to know the conversion factor for grams to milligrams. So you have to know that 1 gram has 1,000 milligrams. Some of you may know the conversion factor that 10 to the negative 3rd grams is 1 milligram. These are the same exact thing. So whichever conversion factor you use, I don't care, but 0.75 grams, and you want to convert that, I like 1,000 here. And so I get 750 milligrams. Oops. You must show this. Just moving over the decimal point is not sufficient for this class. So if you know that KCG thing, that's great for you, doesn't work for us. Okay. Last thing is measuring with a ruler. So, I mean, you have to know how to use a stopwatch and a balance, but pretty much when you use those tools, you record whatever is on those tools. You may not round, but in terms of a ruler, this is the only analog tool we use, and you need to know how to express this correctly. So this is a portion of a ruler, so you can assume that this extends to the left until it reaches 0. So this particular example, it's a little bit before the 66. So I would express that as 65.90 centimeters, which is 0.6590. You have to leave that trailing 0 to measure this exactly. If you thought it was 66, you'd have to put 66.00.